Alright, welcome to the next presentation in the hackathon. We're going to talk about Injective together with CosmWasm. More advanced topics, so more advanced topic on CosmWasm, but also more advanced topics specifically on how we're using CosmWasm in Injective and how you as a developer can use CosmWasm in Injective. So yeah, because together they really fuse together and create something beautiful that is quite unique and not seen somewhere else. All right, so what's important in CosmWasm? That's for one is the messages, and for number two, it's the queries. So let's go into the details on, well, what are the messages that you can send at Injective? How can you send specific Injective messages? And the same for queries. Obviously, messages being super critical here, so you're definitely going to want to see how to send Injective messages. All right, and for that, we're going to look at this repository, Injective Labs / CW-Injective. And in this repository, you're going to find most of the things, probably all of the things you're going to need to interact with Injective. And we're going to go through the repository and I'll show you a quick introduction to it and then how you can use it. All right, so now I'm in CW-Injective and you're going to find All right, now I'm in CW-Injective and in here you're going to find mostly two interesting folders here, contracts and packages. In contracts, you're going to find there's actually two example contracts. Well, one is not really an example contract, it's just a dummy contract that is very useful if you want to start a new contract. So yeah, I highly recommend looking at this and just copy pasting it essentially if you want to start a new contract. It's a good way to get started. And the other one is atomic order example. And this is a very good example contract showing how to do an atomic market order on Injective. And it's a good example because it shows a lot of concepts in one contract. Specifically, atomic market orders in Injective actually means that you execute a market order immediately. And that is actually bypassing the FBA, the frequent batch auctions that we have on Injective. And it means you immediately get a response. So for those of you that don't know, I give a very short intro. Frequent batch auctions are basically at Injective a mechanism to collect all orders in one block, and then in the end you have one unique clearing price for all orders, and that's sort of a front-running protection. But it prevents people or smart contracts from actually executing a market order and getting a response and then reacting on the response, because you always have to wait for the end blocker and have this frequent batch auction happening in the end blocker, and well, then you can't respond anymore in your smart contract because when the end blocker is running and the block is finished, then you can't execute the smart contract anymore. So that was just the first quick intro on why this is even there. And well, obviously there you get an advantage here by being executed earlier. So you're actually paying double the fee. So it's not really that meant for everyday normal users, but more for smart contracts that really want to have this functionality and be able to respond to the atomic market order. So in this example, you can see this is this concept of sub-messages where you can then actually respond to whatever when the market order finished, and then do something which I guess is quite common if you do a market order and you want to do something only if the market order succeeded, and then do something after that. And then also see what was actually the price that I got in the market order. So that's this example. And now let's take a look at packages. And this is what you're gonna want to do when you're writing your own contracts. All right, so here we have Injective CosmWasm, Injective Math, and Injective Testing. So the main one that you're going to need is Injective CosmWasm. So inside Injective CosmWasm, you're going to find you actually have the messages. So let's take a look here. And we'll look at these in a little bit in more detail. but you can find already all the messages that you can use here. And then also some helper functions to actually here, like for example, create subaccount transfer message, and some helper functions to actually create those messages. And the same goes for queries. You're going to find all queries here. And well, also some other types. For example, we have a specific subaccount type. And well, if you're familiar with the address type of CosmWasm, it's very similar to that. And the same we have for market ID. So actually they are in types here. And if you see, we have a pub struct market ID, and it's actually just a string. And the same for subaccount ID, pub struct subaccount ID, and it's just a string. But what it does for you is basically checking if this is actually the expected format string. So does it start with 0x like every subaccount ID and every market ID? Does it have the right length? And only then it's sort of accepted as a subaccount ID. And we have the same for market ID. And then we also have this privileged action here, which is a unique feature in Injective that we're going to talk about in the end. All right, so that's Injective CosmWasm. So this is something that you're going to integrate or add to your cargo in contract, and then use it to actually be able to interact with the Injective chain. Then we also have Injective Math, and this is actually, has a very useful new type. It's FP decimal, fixed point decimal, and I definitely encourage you to use this if you are going. This type is already used in Injective CosmWasm, so most likely you're gonna get exposed to it anyways. But I definitely recommend you to use this type regardless for fixed point decimals, which is not directly supported in CosmWasm, and we do have our own type here and with some extra functionality and functions to make it useful. All right, and then we have injective testing, which probably you're not gonna need that much, but if you really want to dive into the CW multitest, we do have some helper functions for this here. Although I gotta say, we're probably rewriting this soon, so maybe you don't want to look into this at this point, but maybe you are interested, or maybe you even want to improve on it, then yes, feel free to obviously look into this one here as well. All right, so like I said, now let's talk about the messages, which are obviously the most important aspect. And messages are the Cosmos SDK messages. I'm assuming you're gonna know what I'm talking about here. And all the injective messages that exist, you can actually find directly on the docs here, docs.injective.network, modules, injective, exchange, and then messages. So, those are the specific messages for the exchange module. So there are obviously some other modules as well. There's insurance module, auction module, and a few other ones. So just be aware that there are obviously some other modules, but the exchange one is most likely the one that you want and that you want to send messages from. And so yeah, this is the place where you would look what kind of messages exist. And I can already give you a hint what are the ones that you're most likely gonna need. And well, this one little here is probably by far the most useful one. So it's batch update orders, and it actually is one message that just allows you to do basically everything. So it has a feature to cancel all orders or cancel specific orders and create new orders. So, well, for one, that's very useful if you're, for example, market making on Injective, because then you can just cancel all orders, create new orders in one message. But even in general, if you're a trader or you have a smart contract that allows to have multiple things in one, this is a very useful message. So yes, you can provide a market ID and then it's going to cancel all. And if you provide a market ID, you're also going to need to provide a sub-account ID. And then you can provide specific orders for that should be canceled or create newly created ones. Of course, you have all this functionality also in single messages. So everything you can do here, you also have as one specific message like cancel derivative order. So if you only want to do one action, well, then you can look up what is the specific message here for this one action. Then you don't need the batch update. Then you're going to have deposit and withdraw, which if you're using sub-accounts on Injective, this is going to be useful. But if you're not using it, then you probably don't even need those. And the instant launch features, I highly doubt you're going to need those for a smart contract. And other than that, yeah, so that's about the maybe sub-account transfer. Maybe you need that, or external transfer rather, if you want to send from one sub-account to another sub-account. And of course, you always have the native Cosmos SDK messages, right? So if it's from the bank balances, you're going to have the message sent. And message liquidate position, you probably don't need from a contract. Well, unless you have some kind of automated bot maybe that wants to liquidate positions, actually, then maybe you do need this one. And then there's a message exec, which actually has its own separate section, which is also message. And this is a specific one that I'll talk about in the end for the privileged actions on what the deal is with this one. All right, so then the way you would actually create a message would be using these helper functions that I showed you before. And let's take an example. So this would be create spot market order message. So that's the helper message that actually creates the Cosmos message for you. And it is wrapped in this injective message wrapper. But I mean, this is the type that you get returned. So you don't need to worry about this directly. And then you just add it as a normal message in your contract. And well, in this case, this message here would take a spot order. And you can always look in Injective CosmWasm and how these types are specifically defined. But for example, spot order here would be defined with market ID, order info, order type, and an optional trigger price for stop loss or take profit orders. But if you don't have those, then you would just put none here. And then the order info would contain the sub-account ID, fee recipient, which can also be not defined if you don't have one. Although typically I would say always at least set the fee recipient to the smart contract address, and the price and quantity. And the order type, well, you can see here, here's for example the atomic type that we talked about for atomic market orders. And there's also PO, post only orders that, well, they don't really have a meaning for market orders, but for limit orders they would, which means if you only post the order if it's not matched. And if it would be matched, if it would be crossing with any other orders, then it's just being cancelled. So that's the post-only order. All right, so now in your contract, all you need to do is you're basically gonna use this helper function, so this create spot market order message, and pass the relevant information. So in this case, it was this order. For the order, we actually do have even one helper function for creating one. So this new function here, you pass the relevant information to it. And then, you create your response like you're used to it and add message, and then boom, well, that's it. So it's pretty much similar to a normal message. All right, so now for the queries, it's pretty much very similar. So for the queries, the way you're usually quite used to it, I guess, is creating a new query from debs.query. And in our case, you then would use this injective query wrapped around it. This is from Injective CosmWasm, which then has the query functions. So for example, if you want to query a specific spot market, you would do query.query spot market and then pass the market ID. All right, now with this knowledge, let's take a look at the atomic market order example, and let's see how this is done here. So obviously, right, we're jumping right into it in the source, and then in the contract, and then we're going to see, okay, instantiate is probably less interesting for us right now, but the execute. So what happens here is we call swap spot. All right, so before we get into the details, let's discuss what this does on a high level to better follow in the code. So on a high level, what we're doing here is we're letting a user provide funds, using those funds to deposit them into a sub-account, then doing an atomic market order and basically swapping the funds, the coin on the spot market into some other funds. And then we're looking in the response and checking what was actually the price that we got and like how many tokens did we receive back. And whatever is left of the initial funds and the new funds that we swapped, we're both sending back to the user, because you don't know exactly what price you would get when you do this market order. So now you can basically see, okay, if you got a little bit better price than expected, for example, there will be some leftover tokens even from, let's say, the quote asset, and those tokens you also then might want to send back to the user or do something with them. So that's on a high level. And now one more thing that you should know is this repository Injective Labs SDK Go. So let's have a look here. And in here, you're going to be able to find the proto definitions of injective chain. And that's actually going to be useful for our atomic market order here. So in here under proto injective, and then here you find under exchange, you find the exchange module proto files. And then here TX proto is probably the one most interesting. And for example, the one that we're going to be using is message create derivative or spot, create spot market order. So you find that here. So let's take a look. And then here you would also see the response. So this is the response we're going to be using. So let's see how this response looks like. And you could basically get the order hash and the results. And the results consist of quantity, price, and fee. Now, this is a profile. You could just directly use this in your contracts or just copy the relevant parts. So let's go back to the atomic market order example. All right, so let's look at the execute and then here the swap spot. So you basically just pass quantity and price of the quote denom. And then in here, it's already pre-configured for one specific sub-account ID from the smart contract and also one market ID. So this is already pre-configured. And then what we do is we use this order, create a new order, spot order here with the pre-configured market ID and the pass, price, and quantity. And the order type is by atomic to make an atomic market order, which means we can get the response immediately. Now, what we also do is we actually deposit the funds into the sub-account first. We do have a chain upgrade pretty soon that actually maybe you don't need this anymore if you don't want to use a sub-account ID. But especially for smart contracts, actually sometimes it can make sense to handle funds in different sub-account IDs to keep them separated. And so here we do that first, and then we just add this to the response as a message, the deposit first, and then we do the order, and the order would then take the funds from the sub-account ID. And then we create the market order, and you see we do a reply on success sub-message here, and then we have this atomic order reply, and I'm sure you know how these sub-messages work. If not, well, you should read about sub-messages in CosmWasm. But anyway, it means we can actually get a response here. We check if it's an atomic order reply. And in that case, we do handle atomic order reply. And now it's getting a little bit more interesting because, well, now what is the reply that we're getting? And in these responses, well, you do get basically protobuf encoded data, and this decoding can be a little bit messy sometimes, but this is a nice way to see how you can do this with this pass from bytes helper that we added or actually took from somewhere. And with that, all you need actually is the proto file. And you can see here we do have this order reply proto file, which basically just is this order response that we just looked at, the order hash and the data, and also the trade data here. But I mean, you could also just copy, for example, the tx.proto directly that we looked at. And well, back to the code. So then here we have to pass the response. And you would first, well, if you expect, we know this is a market order response. So we can use this message order response type that we looked at before and pass the data. And then we just do the same thing for the bytes within that response to get the actual trade data, the message trade data, which would then contain, you know, what we need here: quantity, price, and fee. Why? Well, because now what we can do is, first of all, we did store before. If you look at swap operation, we did before at. I forgot to talk about that. We did save who was sending for the swap here and what amount of coins they originally deposited. So that's sort of stored in this cache state here. And now we're retrieving it back to get the original data. And then we can calculate, well, what was the actual purchase coins that he received and what did he pay for it, which means the execution price of the market order, not the market order price, but the execution price, so what it was actually matched with. And the fee then would be the execution price. The fee is, is just returned actually directly from the response. And then we can calculate also like what is the leftover coins, because we know, okay, well, there might actually be some leftover coins now. So what we can then do is, first of all, we just restore the funds from the sub-account IDs with a restore message, and then just send them both the purchased coins and the leftover coins. So purchased, then if you, let's say you had a quote denom and you did a swap and you wanted to buy, let's make it more precise. Let's say you have on an INJ USDT market, you had some INJ and you bought, you had some USDT and you bought some INJ. So you put USDT into the contract and you would receive some INJ. So the INJ would be the purchase tokens. But now you got a little bit of a better price than the worst price to find in your market order. And that would be the leftover coins. And we're sending all of that back with the normal CosmWasm bank message sent. And yeah, then we just adding all these messages together for the withdrawing from the sub account for both purchase and leftover, and then the bank message sends. All right, and now lastly, let's talk about some really fun and advanced concepts specific to Injective. So, well, you can see here, you can just write a web app or smart contract or CosmWasm contract, but if you want the true thing, well, you got to write a Wasmx contract. And what is Wasmx contract? It's a very unique way just for Injective. Actually, we have our own module here. If you do want to look at the docs for it, on docs, Injective networks, and then modules for Wasmx. But in short, it is actually a way for self-execution, a self-execution environment for CosmWasm smart contracts. And right now, this is still permissioned and probably will be permissioned for a while for security reasons. So there's not really one example I can show you right now, and you can't just deploy this on mainnet because it is permissioned. But you can definitely already develop this, and it's actually very easy to develop. because all you need is to add one specific function to your contract. And then the way you would register the contract, well, I mean, this is the stuff that is permissioned anyway. So definitely, if you do have a cool idea for a self-executing contract, go and talk to us and see if this is something we might want to add to our mainnet, and then we can show you basically how to register it. But from a contract perspective, all you really need is one function, which is called begin_blocker. And that function is going to be a pseudo function defined in your contract. Well, if you don't know what pseudo functions are, look up in the CosmWasm documentation on pseudo functions. Basically, a function that is executed by the chain itself. Because now it's a self-executing contract. So there's no one actually executing and sending a transaction to the contract. Rather, the chain itself would execute it. And like I said, it's permissioned, so you do have to register this contract first. And it also needs to have gas. So and obviously you need some INJ on the contract to pay for the gas. So it's not like it's free. Everything there is actually paid for. So, and if your contract runs out of INJ, it's gonna stop being executed. Although we do have a deregister hook if you really wanted that, and deactivate hook. So, think about you run out of gas, and just before you run out of gas, you can maybe still cancel your orders, for example. One unique way, the way we're using this, is for decentralized market making. So once we launch this properly, you're going to have some great example code to look at. But yeah, for now, this is still very much work in progress. But you can definitely already implement this. And like I said, it's just a begin blocker function, a pseudo begin blocker function that you need to implement. And then this function will be executed automatically by the chain. And then think about what you might want to do, as the sky is the limit for what you can do with this. So it's fairly simple to use on a contract side, but very powerful. So yeah, if you do want to build something like that, definitely send us a message and ask us if this is something maybe even for mainnet. And the last thing is a unique thing that we implemented. Is called message privilege execute contract. Actually, the message exec that we saw before in the docs was the old name. We have to update that. It's called message privileged execute contract. And what you can do with that is two features. One is position transfer and one is synthetic trades. The position transfer is very easy to understand. So that's what it would look like from a code perspective. And we actually have used the set data functionality here from CosmWasm to achieve this. So the way this would work is in Cosmos SDK, usually you would call this function called message execute contract and execute a smart contract this way. But now you would have this new one, message privileged execute contract. And you don't really need this directly in your contract, but someone else interacting with your contract, well, if they want this, if the contract is using this functionality, then they should use this message privileged execute contract to execute the smart contract. And from a smart contract perspective, the way you write it is actually fairly simple. So if you want to do a position transfer, this is the position transfer action defined. And it's just defining a market ID, a source sub-account ID, a destination sub-account ID, and a quantity. And well, I think it's pretty self-explanatory. It basically just means you would transfer some position from your smart contract to the user. So why is this even a privileged action? Why couldn't we just allow this in a normal message? Well, think about a normal position transfer. That's actually would be a pretty big security issue if you could just transfer a position to every random sub-account ID in the chain. Because now you might have like a long position for INJ and somebody sends you a short position of double the size, and now all of a sudden you have a short position for INJ, even though you technically got some money in the moment it happened. If you don't realize it happened and it just stays open, you might lose a lot of money. because now you have a short position and you thought you had a long position. So that's why it has to be this sort of privileged mechanism. And this is safe because, well, if somebody is calling message privileged execute contract, well, we kind of assume that he's trusting the smart contract. And the smart contract can only do what the smart contract has defined in the code. So the smart contract, then you can assume in your code that the sender is trusting that you're allowed to send him a position. So that's exactly what we do here. And the way this works is not with a normal response, but rather with this set data. And that's basically just a way to where you serialize this. You can use this to-binary function from Cosmos SDK, from CosmWasm STD, and basically serialize the position transfer action. And just add it to the response like that. And similarly, we also have a synthetic trait, which is the same thing, but now we're not transferring a position, but rather we're doing a synthetic trait. So not a real trait, but like a trait simulated between the smart contract and you, where we are actually increasing the position from you and the smart contract. So, for example, you would increase the position of the smart contract by 5 long, and then if you do that, you need an opposing side, for which in this case would be the person calling the smart contract, and you would increase it by a quantity of 5, but in the opposing direction, so short. So essentially a synthetic trait on a derivative market. Right, so thank you for listening, and definitely reach out to us if you have any questions, especially about the last parts, which are very much work in progress and very new concepts. So feel free to ask us if you want to touch on any of those. Thank you.